So today we are class. We are discussing the lesson a postulate of classical statistical mechanics. Postulates of classical statistical mechanics. That is chapter. So that subtopic is postulate of equal a priority or probability. Priority or probability. So this is today you have to discussion page number 25. Page number 25. So connection between statistical and thermodynamical quantities. This is very important question, Amma. Connection connection between between statistical statistical mechanics, statistical and thermodynamic thermodynamical quantities. 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 This is very important question. This is a 10 marks question. This is also important question. 10 marks question. Okay. So here already we have to see in the system of the equilibrium, the
Sir, page
entropy.
number, sir. Sorry.
Page number 25 and
25. Okay, sir. Thank you, sir.
yes, sir. Page number 25. The entropy sigma is given. The entropy sigma is given by sigma is equal to sigma into E comma Hc comma Ni. The entropy the entropy is given by is given by is given by sigma is equal to sigma into E comma Hc comma Ni. Ni. If the coordination are changed is the slightly, the reversible is such that the resulting in the system is also equilibrium. This is d sigma. D sigma is equal to dou sigma by dou E into dE plus summation E into dou sigma by dou Hc plus dHc plus sigma I into dou sigma by dou Xi into dXi. That is the formula. D sigma is equal to dou sigma by dou E into dE dE plus summation E into dou sigma by dou HCE into dHCE plus summation I into dou sigma by dou ni into dni. That is, yeah, X terms also. Nm, this is first, this is xi and you change that value, x or n value. You are observe all of you that. xi, this is not ni and this is xi. So here is also xi, here is also xi. Okay. So that is the formula, is the simplification of this formula. Dou sigma d sigma is equal to dou sigma by dou e into dg plus summation g into dou sigma by dou xe. Here is also same the summation and this is also is summation same. Summation here g. Okay. Dou sigma. So that is the simplify the already is the given dou sigma by dou e is equal to 1. Dou sigma by dou e is equal to 1 by 1 by 1 by small tar, and dou sigma by dou sigma by dou xe dou xe x dou x not xe, that is xi xi is equal to minus mu i mu I by small tar. Okay. So that is d sigma by d sigma by d sigma is equal to d is substitute these values, this place and this value is substitute your formula. Okay. So d by d by d tar plus 1 by tar summation 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 e xe d e d dxe minus 1 by tar 1 by tar into summation i mu I dxi. So this is the simplify the equation. de is equal to torque d sigma plus summation I mu I dxi minus summation e xe dxe. So this is also dxi and you are also change that one. That is a small n or n value is out that one. That is also you are observe that one. So as the formula, the let the number of particles number of particles that is you are observe and this is ni and xi value. That is one doubt. I think this is a ni value only, not xi. Is the formula change is not that. So here is also ni. The printing mistake and this is the correct printing mistake. Actually, this is the ni value. Here is next. This is also. Next, this is also. This is okay. Here is also Ni. Here also, where is Ni? Xi plus total is Ni. Ni. That is what Ni. So the number of particle Ni be the fixed and the Hc the number are only external parameters volume. External parameter volume. External parameter volume dni is equal to 0 and Hc is equal to V, comma Hc is equal to V, comma and Hc is equal to capital Phi. Capital Phi. The substituting in the above equation, from the above equation 4.15, that is the substitute in the equation dg is equal to dg is equal to dg is equal to torque d sigma minus 5 dv 5 dv. This is the equation change. The internal energy dg, internal energy dg has two parts. That is, first part is d sigma, a torque d sigma. Second one is 5 dv 5 dv. So that is the value. The first one is the torque d sigma represented the change in the internal energy, when the external parameters are kept constant. are kept constant. Constant. So the second term 5 dV, 5 dV, the change in the internal energy, the caused by the change in the external parameters, that is equivalent to mechanical work. So that is the mechanics. The work does not, the work done. So here the work done must be P dV. P dV, that is capital pi is equal to P. Capital pi is equal to P. So from the relation T ds minus P dV, from the relation T ds minus P dV is equal to dg. So you get the formula, that is converted to equation T ds is equal to T sigma. The S and sigma and torque and capital T are proportional to the proportionals. That is the proportional number. Okay. So so S is equal to S is equal to S is equal to uh, S is equal to what? K sigma. S is equal to K sigma and sigma torque is equal to KT. The K is the constant constant of proportionality. The Boltzmann constant. Boltzmann constant. Boltzmann constant. Boltzmann constant. The Boltzmann constant, we have to formula Boltzmann constant, the dE dou E by dou sigma into y. Here we get dou E by dou sigma is equal to dou E by dou sigma to V is equal to torque. Next to pi is equal to capital pi is equal to minus dou E by minus dou E by dou sigma into here V amma. This is V. Here is sigma. Function is sigma. Okay. So the generally the torque and P are torque comma V. That is the work with, that is the value. Let us the thermodynamical potentials like Helmholtz free energy. Free energy. The enthalpy H value and Gibbs free energy. ఈ ఫార్ములాస్ గిబ్స్ ఫార్ములాస్ ముందు బిఫోర్ వస్తాయమ్మా, అది చూడండి దీనికంటే ముందు పేపర్లో. Gibbs free energy G, the related to the above the particle, which is useful of obtaining the key parameters. The Helmholtz free energy F value Helmholtz free energy the particle F value, this is F. So F is equal to V comma torque. V comma torque is defined by is defined by F is equal to E minus Ts is equal to E minus torque sigma. The same time the df derivative, the df is equal to dg minus ts, d minus you write this d minus torque d minus torque d sigma minus sigma d torque. So that is the total value. Already you know this value. Yeah, this value 5 dV minus 5 dV. Already before the class in the mundu chesam madam ikkada before the value this value, the formula, convert the formula minus capital 5 dV. That value is up here formula before formula. So df is equal to minus capital 5 dV minus sigma d torque. Okay, as the f is function of the volume and f is a function of v and torque. Here f value, this is the f value, function of the value and torque value. So df is equal to dou f by dou v dou v into torque minus torque dv 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 plus dou f by dou torque plus dou f by dou torque into v into d torque d torque. The comparison else the comparison phi is equal to phi is equal to capital phi is equal to what? Minus dou f by dou v minus minus sorry minus dou f by dou f by dou f by dou f by dou v torque comma sigma is equal to minus dou f by dou torque into v to v. That is Helmholtz free energy value. Next, second one, the enthalpy. Enthalpy. Second one is enthalpy. Enthalpy H value. Enthalpy H value. That is, so here enthalpy value H is equal to H is equal to E plus PV. H is equal to E plus PV PV E plus PV is equal to E plus 5V. E plus 5V as a formula. So this is also your derivative. DH is equal to DG plus PDV. This one derivative DH is equal to DG plus PDV is equal to PDV plus 5dV plus this is convert the phi dV. Okay, so here 5dV totally d torque dV torque d sigma. This is the value torque d sigma plus this value v d 5 plus 5 dV 5 dV. Okay, so that is H is the function of torque comma phi value and dH by dH is equal to dou H by dou sigma into d sigma plus dou H by dou phi into d phi. 1 minute only. సారీ అండి, అది ఎక్కువ మార్కర్ కలర్ చేంజ్ కావట్లేదు, అది చేంజ్ అవ్వట్లేదు. నెక్స్ట్ GH మాట్లాడలేదు ఇంత కొంచెం. DH is equal to dou H by dou sigma into d sigma plus dou H by dou pi into d pi d pi hence torque is equal to dou H by dou sigma into pi value pi and V is equal to dou H by dou pi into sigma. The free gives third one is gives free energy. Gives free energy. Free energy gives free energy G value. Okay. So the G into torque comma P is defined as G is equal to E minus torque sigma plus PV. The simplification that simplification of dg is equal to minus sigma dv minus sigma d torque plus v dp and dg is equal to dou g by dou torque p and v is equal to dou g by this is dv is equal to dou g by dou p into torque. As the entropy and the probability are related as S is equal to KLN log n P. K log n of P. The P is the probability. The equilibrium state is the maximum probability. This is 5 marks question or 10 marks question scheme, amma. Okay, this is also important question, that one. Almost 60% of it came this question examination. 5 marks questions came, that one. Okay, sometimes is given the 10 marks. So next question, page number 30. Page number 30. మార్కర్ చేంజ్ రావట్లేదు అంటే కలర్ పోవట్లేదు, అది ఎందుకు వస్తుంది? So next question you are discussing the value, page number 30. Definition and explanation of microcanonical ensemble. That question you read, Andy. Okay, that is also 5 marks question, is an important question. Okay, definition and definition and explanation of microcanonical ensemble is also you read. Next, perfect gas in the microcanonical ensemble. Perfect gas in the microcanonical ensemble. This is also 5 marks question. Today almost 5 marks question is came the so the perfect gas in microcanonical ensemble. This is also only 5 marks question only. So this is also only 5 marks question. Let us consider the microcanonical ensemble of perfect gas with a particular of mass m in the volume V, the energy range E and E plus delta E. Now the volume of phase space, the delta torque is given by let us consider the microcanonical ensemble of perfect gas with the particle of mass particle of mass m, small m, mass m, volume V, the energy range E and E plus delta E. Particle of mass m value volume V, energy range of E, value range E and E plus delta G. The volume of in phase space, volume of in phase space delta torque delta torque. So here delta torque is equal to integral of dq1 dash dq3n 3n dimensional. So 3n comma integral of dp1 dash dp dp3n. So that is the formula. So here q value is the position, p is the momentum coordinates, p is the position, p is position, uh, q value is momentum of coordinates. So coordinates, the momentum coordinates in the perfect gas interaction the between the particle, and hence the energy of particle gas, energy of perfect gas in the independent of position of particle. Position of particle. The position of particle real of dqi dqi dash d dq3n is equal to v power of n in the dimensional. The same from delta torque is equal to v power of n real of dp1 dash dp3n dp3n. The evolution of the momentum, momentum integral, the constant is the constant is which one? E minus delta E less than or equal to E less than or equal to ER less than or equal to less than equal to G value. So that is E is equal to E minus delta E. So this value delta E less than or equal to summation I is equal to 1 and 3n pi square by 2m less than or equal to m, less than or equal to portion of the mass value, less than or equal to portion of the mass value, that is m, that is m. 2 by m is equal to e and g. Okay. So the integral, the volume containing between the 3n dimensional hypersphere of the radius 2m 2mg power of 1 by 2 and 3n dimensional hyperspace of the radius 3n dimensional the hypersphere of the radius of 2m into e minus E minus delta E of 1 by power of 1 by 2. Power of 1 by 2. The simplification, their integral, the simplification, their integral 1 obtain the integral of dp1 dp1 dash dash dp1 dash dash dp3n dp3n is equal to is equal to is equal to uh, 5 power of 5 power of 3n 3n by 2 3n by 2 into 2mg 2me power of 1 by 2. Sorry, there is also 1 by 2 plus here 1 by 2. So 3 by 2. This is a 3 by 2. So 3 by 2 integration only. That is, so 3n by 2 into factorial. Okay. So this is the derivative is the formula. They have multiplied the torque. So delta torque is equal to power of v power of n 5 into 3n by 2 3n by 2 3n by 2 into 2mg this equation 2me 3 5 by 2 3 by 2 3n by 2 into 1 factorial 1 factorial. The classical structural mechanics, the entropy of sigma of the system in the statistical equilibrium is given by is given by is given by is given by sigma is equal to log G torque. Sigma log G delta torque. So the sigma is equal to sigma is equal to n into log e n into log e into v power of n into v power of n into pi 3 n by 2 to into 2mg 3 by 2 into 2e by 2e by 2e by 2e by 3n 2e by 3n power of 3n by 2. That's all. 3 by 2. So the largest of the value formula is converted to that one. So here next derivative the larger n log e into v minus into 4 pi 4 pi m by 3 4 pi m by 3 3 by 2 3 by 2 e by 2 e by n by 3 by 2 e by 3 by 2 plus 3n by 2 plus 3n by 2. That is 3n by 2 small n 3n by 2. The entropy it should not be dependent upon the units. Should not dependent upon the units. The hypervolume delta torque. The hypervolume the hypervolume delta torque and the delta torque is the dimensionless. Delta torque is the dimensionless. The delta torque is replaced by delta torque replaced by delta torque delta torque by delta torque by h power of 3n, h power of 3n, that is sigma is equal to log n log n of that is ln, the delta torque by h by h by h 3n power of 3n plus n sigma naught, n sigma naught, that is the multiply is the sigma naught value. So sigma is equal to n n ln of v into e by n e by n e by n 3 by 2 plus n sigma 0, n sigma 0. The sigma 0 is where sigma 0 is equal to 3 by 2 into ln of so this value you write this ln of the total value you write this ln of 4 5m by 3 sorry 4 5m by h square h square h square h square, that this value is 1, that is equal to plus 1, you know, plus 1 is equal to, that is the plus 1. The expression is the correct the entropy. Sigma is not additive, the because of the volume v occurs in the arrangement of logarithm. The difficulty is not remove the essentially the leads to a called the Gibbs paradox. The accept the properly the accept the properly the accept the properly okay. So the properly additivity, the sigma is such useful. They are arriving at the thermodynamics. Thermodynamics is also the internal energy. This is four type of equations. That is internal energy. Torque is equal to kT. Third one is relation between the torque and p value. Is chemical potential mu. Chemical potential mu value. That is the four cases, that one. So that is the internal energy. Internal energy. The internal energy. We know the 1 by torque is equal to dou sigma by dou e of dou E of V dou sigma by dou V by dou E V comma N V comma N V comma N. The dou by dou E that is equal to dou by dou E into 3n by 2 into log G log G. So this is the dou by, that is the dou by dou E into that one. So V and N are value is a constant. V and N is a constant. The 1 by torque is equal to 1 by torque is equal to 3n by 2 into 1 by E. 3n by 2 into 3n by 2 into 1 by E. 1 by E. E is equal to 3n by 2. E is equal to 3n by 2 into torque is equal to 3n by 2 3n by 2 into kt. Kt means kt and so that's torque is equal to kt. Before equation I am telling this one already. Okay, so torque is equal to 3 by nt. So finally you multiply this, so that is 1 by torque is equal to 3 by 2 into n k t. This is the internal energy value. Next to B is the torque is equal to kt. That is a formula. ఈ వాల్యూ సబ్స్టిట్యూట్ చేసాం కదా, అది సేమ్ ఫార్ములా. టార్క్ is equal to kt. Torque is equal to kt, that one. Next to C, the relation between torque and P. The relation between torque and P. The relation between torque and P. Already the P by torque is equal to dou sigma by dou V. The third one now. Relation between torque and P. Torque and P. That's the torque and P. So that is P by torque is equal to dou sigma by dou V into n comma E V. That is P by torque is equal to small n by V. That is small n by V, or PV is equal to n torque. That is PV is equal to n torque. PV is equal to n torque and NKT. That is PV is equal to NKT. So next the chemical potential. Next one is the chemical potential is D is chemical potential. That is a chemical potential. Mu is equal to, this is a chemical potential, the perfect gas of the equation, that one. The essentially we get mu is equal to torque log P plus F of torque. So that is the already you know torque is equal to what? KT. So that value substitute there. So here KT into log KT into log P plus F of KT. F of KT. So F of KT, F of KT, the expression for the entropy is not correct. The require the modification. It is not additive and uh, leads to the what is called the Gibbs paradox. Gibbs paradox, which can be resolved by the replacing v by v by n. That is the logarithm. Okay. So this is also only 5 marks question. The Gibbs paradox also sometimes came your examination. So that is one tick mark అండి 5.4. గిబ్స్ పారాడిక్స్ లో మీరు 3-4 టైమ్స్ అడిగాడండి థియరీ ఎగ్జామ్ ప్రాక్టికల్స్ లో సారీ థియరీ ఎగ్జామ్ లో ఓకేనా దట్ ఈస్ ఆల్సో యూ ప్రిపేర్ దట్ వన్ సో నెక్స్ట్ క్వశ్చన్ నెక్స్ట్ వన్ పేజ్ నెంబర్ 34 పేజ్ నెంబర్ 34 partition function and thermodynamical parameters partition function partition function partition function thermodynamical parameters సో మీరు మ్యాక్సిమల్ బోల్ట్జ్మాన్ స్టాటిస్టిక్స్ చెప్పమని మెసేజ్ పెట్టారండి అది నెక్స్ట్ క్లాస్ లో చెప్తాను ఇప్పుడు ఎందుకంటే ఈ క్లాస్ లో మీకు టైం అనేది కవర్ కాదు అది 15 minutes లో అయిపోదు ఆ క్వశ్చన్ ఓకేనా నెక్స్ట్ క్లాస్ లో కంపల్సరీ స్టాటిస్టికల్ బోల్ట్జ్మాన్ స్టాటిస్టిక్స్ గురించి కంపల్సరీ చెప్తాను మ్యాక్సిమల్ బోల్ట్జ్మాన్ ఓకే సో దిస్ ఇస్ ఆల్సో ఇంపార్టెంట్ partition function and thermodynamical parameters ఒక నిమిషం అండి 1 minute ప్లీజ్ అక్కడ ఉన్నాను అదొకటి Next, partition. Partition function. Partition function and partition function and thermodynamic. Thermodynamic parameters. Thermodynamic parameters. Parameters. This is also only 5 marks today. Almost is a 5 marks percentage came on this for exam. Okay. So the partition function. Here the partition function. Partition function. Let us the ideal gas molecules. The partition function. Let us gas the molecules. Say the classical distribution law. The classical distribution law. That is Maxwell-Boltzmann distribution law. Depending on the Maxwell-Boltzmann distribution law, the according to these laws, according to these laws, according to these laws, according to these laws, according to this law, the NR molecules and molecules occupy the earth state, the energy between ER and ER plus DE, the degeneracy, the degeneracy, the degeneracy GR, the degeneracy GR, energy between molecules, the according to the laws, the molecules, that is NR is equal to GR e power of minus a exponential of minus ER by KT by KT by KT. The GR is equal to the GR into this is exponential as the value A is equal to e power of minus a. That is A is equal to e power of minus e. That is a. So that value is substituted there. So GR is equal to A into A into A into exponential of minus beta ER minus beta ER here A is equal to e power of minus a and beta is equal to 1 by kt 1 by kt, that is say. So the total number of molecules in the assemblies n is equal to the total molecules is capital N is equal to summation R N R is equal to A into summation GR exponential of minus beta this value beta beta ER into G into beta R is equal to is equal to is equal to is equal to Z is equal to Z. The Z is called the Boltzmann partition function. Here Z value is Boltzmann partition function, and the simply the partition function simply the partition function the term this is the right GR value, that is the term of the partition function, the term summation GR exponential of minus beta ER minus beta ER. That is the partition function. The term of summation GR exponential of minus beta ER. The represented the sum of the GR exponential of minus beta ER. The term of every state, the term is the every state of is given molecule. The consequently the quantity the quantity Z indicates how to the gas molecules of assembly are distributed are distributed are distributed the partition among the various energy level and call the partition function. The considering the weight gr and the individual level as unity, the individual value is the unity. Z can be written as z is equal to exponential of z is equal to what? Exponential summation of exponential minus beta ER That that is the partition function. This is the partition function. That is the partition function. Next to thermodynamic quantities through the partition function. Thermodynamic quantities through the partition function. So partition function. The thermodynamic is the quantities that through the partition function, that is different type of partition function. First one is entropy, Helmholtz energy F and total energy enthalpy H value, Gibbs potential G value and pressure P and specific heat and constant volume CV. This is type of the thermodynamics. Okay, first one is entropy, Helmholtz energy value F value, the total energy. Next to enthalpy H, Gibbs potential G, and pressure P, specific heat and constant of value CV. That's the values. Okay, so that is a simplify. First one, entropy. The entropy is related to the weight. The entropy related to the weight W, the most probable configuration by S is equal to K log W maximum. W is the maximum value. maximum. The simplifying the after applying the Boltzmann distribution law and the constant of n is equal to constant of n is equal to capital N is equal to summation nr and g is equal to summation nr gr nr gr nr and er. The large w maximum w is equal to n plus large z plus beta e. So z is the partition function is given by this z value is this. So z is equal to summation here. Z is equal to summation e power of minus beta gr. But so that value support this. So that is a large w maximum value. So s is equal to s is equal to s is equal to kln w maximum value maximum is equal to kn 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 large z large z large z plus e by t e by t. So that is e by t. So here you are observe this is the e is equal to already I telling this e is equal to 3 by 2 into kt. So here e is equal to 3 by 2 3 by 2 3 by 2 nkt. Okay, so that value here. So s is equal to substitute this s is next to e is equal to 3 by 2 nkt. That value substitute here. S is equal to k n large z plus 3 by 2 nk is equal to kn 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 large n z plus 3 by 2 nk 3 by 2 n k. You also you convert this is also n capital n k. Okay, so that is the entropy value. Next second one is Helmholtz the energy F energy F. So that is the formula F is equal to F. So here F is equal to E minus Ts. E minus Ts. So already you know E value before the E value. So here E value you have support that one. Minus nkt large z is equal to minus nkt large n z So the next total energy. Next one is total energy. The next one is total energy. Third one, total energy. The total energy, the E is equal to, that is total energy, E is equal to Ne bar is equal to, so you know already Ne value, so that value convert the Ne bar is equal to N K T square N K T square into dou by dou T dou by dou T Ln Z Ln Z into T into T. Sorry, Ln Z into is the value V amma V. So next one is fourth one. Fourth one, the enthalpy. Enthalpy, that is H value. That is H value. So here the H is equal to E plus PV. H is equal to E plus PV is equal to PV is equal to RT. PV is equal to RT. So here PV is equal to RT. So that value is put there. E plus RT. E plus RT. That value is put here. E plus RT. So here already you know E value. Already you know E value means E value which one? Total energy formula. E value E is equal to this gamma. This value has appeared here. These formulas. Okay. So N K T square into N K T square into dou by dou T Ln Z B plus RT. B plus RT. The total value is equal to this value substitute. Okay. RT. That is the formula enthalpy H value. Next to fifth one and Gibbs potential. Gibbs potential. Gibbs potential, that is G. Gibbs potential, that is G. So the G is equal to Gibbs potential formula. G is equal to HTS. G is equal to H minus TS. H minus TS. So already the HTS, H is equal to what? H is equal to RT. So this is H is equal to gamma. This total value is H value. So that value also you have substitute here. Next TS value before equation, TS value is same that one. So that value is finally substitute there. So finally is RT minus NKT Ln Z value is same value. So this is H value in total substitute this value here. Here H value, this is your total value is substitute this. After TS value, some value came. TS value is also this value. Okay. So remaining this value, another value is a total is a cancel. Remain the value. The RT value and NKTLN values remaining value. That value write this. So H minus TS is equal to RT RT minus NKT Ln Z minus NKT Ln Z. That is Gibbs parity, Gibbs potential value. Next to pressure. Next, pressure P. Pressure is P. This is also the P is equal to minus P is equal to minus dou F by dou F by dou F by dou V into torque. First starting equation వచ్చిందమ్మా ఇది torque. Dou F by dou V, dou F by minus dou F by dou V into torque is equal to you write this formula. You write this is equal to n is equal to what? This one. So is equal to nkt is equal to nkt into dou by dou V into dou by dou V into lnz into lnz t lnz t. That is a pressure value. Next to final equation 6.1, the specific heat. The specific heat at the constant of value. Volume CV. Volume CV. That is equal to CV. CV is equal to dou E by dou T into V is equal to NK to ZT into dou by dou T lnz plus t square into this del square by dou t square into lnz into of V. The advantage of the partition function is the thermodynamic parameters are related to the logarithm of partition function lnz, and hence the thermodynamic parameters correspond to the different type of the motions, etc. That is the partition function and thermodynamic parameters. That is question. And this is also only 5 marks question. Okay. So thank you, and the class is completed. Thank you.
Thank you, sir.
Okay.
Thank you, sir.
Okay, well.